right, kiddos, so today we're looking at notes for 2-4, perfect and non-perfect squares. Definitely stuff you've talked about in 8th grade, and we sort of have talked a little bit about this stuff this year too, but we're going to officialize it here. So the square root of 36, yes, that is what that little swoopity-swoop thing is called. That's a square root, or a radical. We'll get into that more soon. So here we have the square root of 36 equals. And naturally, if you weren't sure about that, you could jump to your little fancy calculator that we all have now because we're cool. Let's make that a little bit bigger. Okay, so your square root is right near the x squared. See, it's that little swoopity-swoopity-swoop. You have to press the second button first, and then to get your square root, 36, enter. So we can see that the square root of 36 is 6 if you didn't know that beforehand. And the reason the square root of 6 is 36, this is because 6 times 6 is equal to 36. That's where those pieces come from. Just like if we looked at the square root of 81, that would be, and again, if you don't have these memorized, that's okay. I think Mrs. Goodhue wanted you to memorize them last year, but, you know, square root of 81, or 81, yep, the square root of 81 is 9, and again, that's because 9 times 9, 9 times itself gives me that 81, or 9 squared equals 81. 6 squared equals 36. 9 squared equals 81. Those are both examples of what are called perfect squares because they come out to be that nice, normal whole number. 6, 9, 7, those kind of things. So we've got our perfect squares right here, and this is just going to come in handy when we get into some later lessons. So if you're not sure about these, go through, plug them all in your calculator. Maybe you'll recognize the pattern. If not, just go through and put them in. Square root of 1 is 1 because 1 times 1 is 1. Square root of 4 is 2 because 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 5 times 5. And you might be recognizing the pattern here. Oh, oops, 10, 12, 13, 14, 225, all the way up to 17. Now, naturally, there's an infinite number of perfect squares, right? I could keep going. 18 times 18, 19 squared, 20 squared, 21 squared, 22 squared, all the way up to, 10,000 squared. They would get a little ridiculous, and we won't ever get that ridiculous. But just know that there's an infinite amount of them. Let's actually write that down. There is an infinite, an infinite amount of them. It's an important fact. Okay, cool beans. So then we have our non-perfect squares, which are everything that's not a perfect square. Any other number under a radical that's not a perfect square. So non-perfect squares, any other number under a So if I know that the perfect squares are the square root of 4 and the square root of 1, everything in between there would be the square root of 2, the square root of 3, not the square root of 4, but I could skip to the square root of 5, the square root of 6. And if I look at those, if I look at those numbers in the calculator, the square root of 2, the square root of 5, the square root of 6, you'll notice that every single one of those numbers is a never-ending, non-repeating decimal, making it irrational. And furthermore, if I try to do that math frac trick with these, you'll notice it doesn't put it into a fraction because it cannot be written as a fraction because it's irrational. Your calculator is a great tool to help you figure these problems out here. So let's get some more, square root of 101, square root of 120. 121 is perfect, but 120 isn't. Notice the square root of 120 will be very close to 11, but not exactly. Let's look at that. The square root of 120, oops, not 120, 120 is 10.95. Really, really close to 11, but not exactly because it's not that perfect square. And all non-perfect squares are irrational numbers. Let's jot that down. Let's use blue. All non-perfect squares are irrational. Okay, cool. We'll look at perfect square equations next.